Hi there, everyone. We've been talking a lot about homeostasis lately, so I wanted to very briefly go over a very good example of homeostasis in action. So this is not what you would call a physiological example. We're going to be talking about the heating and air conditioning units in your home or apartment. So not a physiological example, but what you're going to see here is that the way your air conditioner and or heater operates is almost identical to the way your body operates for managing things like your body temperature, your blood glucose, your blood pressure, etc. So what we're looking at here on the left side is what your house is going to be doing during the very hot summer months when the temperature outside is, say, something like 95 degrees. So very commonly, I'll usually ask about this in class to ask people, okay, what do you usually set your thermostat at? What's a comfortable temperature for you? And very common answer is about 72 degrees Fahrenheit. So what we're going to do here is we're going to put a data point here right at the very beginning at 72 degrees Fahrenheit. So to start off with, we are going to assume that whatever your HVAC system is doing, whether it's the heater or the air conditioning, right now it is not on. It is currently off. So if it is 95 degrees outside and the sun is just radiating heat towards your house, very naturally the temperature inside your house or apartment is just going to start going up. So we're going to get this upward climb in this graph. We are deviating from our set point of 72 degrees Fahrenheit. So if you set your thermostat at 72 degrees Fahrenheit, what you are telling your thermostat, your HVAC system, what you are telling it is that on average, you want the temperature in your house to be 72 degrees Fahrenheit. But as you are aware from our discussions on homeostasis, it's not going to always be exactly 72 degrees. That's what these two red dotted lines are for. That is our normal range, meaning all of the values that fall in between those two dotted lines are permissible. We can deal with that. So we have an upper limit of 73 degrees Fahrenheit. We don't want it to get any warmer than that. And we have a lower limit of 71 degrees Fahrenheit. So the average of those two limits is our set point of 72 degrees Fahrenheit. So as we were saying, with our air conditioner off and it being very hot outside, we are going to start climbing up and up and up in temperature until we hit that upper limit of the normal range. So as soon as we get the house warmed up to 73 degrees Fahrenheit, your thermostat is going to act as both a sensor and a control center here. Basically, it receives this information about the temperature in your house, interprets it as being too warm, and it is going to send an output signal to your air conditioner saying, okay, the temperature inside the house is currently too hot. We need to do something about that. The air conditioner is the perfect person for the job here, right? So at this point, as soon as we hit that upper limit there, we are going to turn the air conditioner on. And when the air conditioner comes on, we are going to start blowing cool air through the vents and into the house. And this is going to bring the temperature back down. So the air conditioner is going to stay on, blowing cool air into the house until we reach the lower limit of the normal range. So at this point, after we've had the air conditioner on for a certain amount of time, your thermostat, again being the sensor and the control center, is going to interpret this as, okay, we've had the air conditioner on, but now things are getting too cool. So what's going to happen here is that the air conditioner is going to turn off. And when the air conditioner turns off, then the radiation from the sun is going to heat things back up, and we are just going to repeat this process again and again and again and again. The house will warm up again until it's time to turn the air conditioner back on. The air conditioner will cool the house until it's time for the air conditioner to be turned off again. So you've noticed, I'm sure, during the summer months that your air conditioner is not on all the time, right? So there are times when your air conditioner is on, blowing cold air in, and then after a certain amount of time, it shuts off. So the purpose of this is it is going to save energy. You don't want your air conditioner blowing all the time because your utility bills would be through the roof, right? In the human body, it is exactly the same. We want to conserve our energy. We make a finite amount of ATP energy from the food that we eat, so we want to make sure that we are using it and budgeting it appropriately. So for these homeostatic mechanisms, we want to save energy by making sure these mechanisms are only on when there is a stimulus, meaning that some parameter, like your body temperature, is outside the normal range. Okay, so let's now move on to this example over here. So air conditioning is a perfect homeostasis mechanism for when it is very hot outside. As you, I'm sure, can imagine, it's not going to be appropriate for the winter months, say when the outside temperature is below freezing, like say 20 degrees Fahrenheit. So if we kind of complete this graph here and then get back to our set point here, transitioning into the winter months, so winter over on the right side of the graph, now we have kind of the opposite problem. If there is no HVAC system operational currently, the outside cold air is going to naturally bring the temperature of your house down. So the temperature of your house will now decline again until we hit the bottom part of that normal range. Previously, this would be the point where the air conditioner turned off, but having the air conditioner off is not going to in any way prevent the temperature inside the house from continuing to decline. So for that reason, we need an alternative mechanism here. So the air conditioner is not going to do us any good, so this time we need the heat. So this time, this is going to be where we turn the heat on. So with the heater on, the temperature inside the house starts to go up. We are blowing warm air through the vents this time. And you kind of get the idea by now. After a certain amount of time with the heater on, the house is going to warm up until it gets too warm. And your thermostat will interpret that and say, okay, this is the time to turn the heat off. With the heat off, the outside cold air will again bring down the temperature inside the house until we get down to the bottom here again, at which point it is now time to turn the heat back on. And just as the case was with air conditioning, we are going to be repeating this cycle again and again and again. But the very nice thing about it is that we save a great deal of energy by not having these mechanisms on when there is no need for them to be on. So heat off. So the fact that we have two mechanisms, both heating and air conditioning, we use those two mechanisms to take care of our two possible stimuli. And for any parameter, there's always going to be two possible stimuli if you're dealing with a normal range. Either your stimulus is the parameter is too high or the parameter is too low. So in the case of your body temperature, and we can draw a lot of parallels from that to this example, for your body temperature, you have a mechanism for when your body temperature gets too high. That's what sweating is all about. You have a separate mechanism for when your body temperature gets too low. That is your shivering mechanism. So just as the case was here, we have two mechanisms for dealing with any potential type of homeostasis deviation. Sweating and shivering for body temperature. Insulin and glucagon for blood glucose. So as we progress throughout the semester, we are going to continue to see a lot of examples of how homeostatic mechanisms need to leap into action in order to correct deviations from a normal range. So I think going through examples like this is ultimately going to be very beneficial in the long run, not only because all throughout your life, you've seen your heater and your air conditioner at work, but now you can kind of see how those sorts of things very much directly apply to how the human body operates. So we'll go ahead and end it there. Thank you very much.